Hello, so this is the technical breakdown video for my PCG module. So my project is demonstrates the communication between Metasound and Niagara, so the two informing each other to do certain things, as well as an intensity map that is grayscale between 0 being white, 1 being black, and the intensity makes the effects more powerful and changes them between a normalized variable between 0 and 1. So the effects are spawned randomly within a range. They also spawn at a range between certain intensities. For the sake of the example, the spectral man only spawns at 1, so when it is just black, and the other effects spawn from 0 all the way to like 0.95. So I'm just going to go over essentially how the system works. So essentially on spawn, the an effect is chosen based on the current intensity. The intensity is then fed to the effect template. This can be overridden if you wanted to change it, but for now it uses this effect template. The effect template has 4 major ways of communication. The entire system can do 4 different ways. That is the sound effects to the V effect, which is the first one. It's fairly straightforward. You take the output of meta and you pass that into a user parameter float in the Niagara. Then the reverse is also fairly simple, a bit more complicated because you have to have a object that the Niagara system interfaces over to and sends the data that way. So you can't just send the data through an event dispatcher. You need to have an object that captures that data. Then the more complex 2, which came through development of just effects that were just flat out needed, which is Niagara floats to meta executions, so it will evaluate the float and then determine via true or false if an execution should be triggered. So this is especially great for like one shots and sort of triggering one specific thing in the effect rather than turning the volume up or down, because Metasound it doesn't really work that well with just purely that. Metasound very much requires executions. Niagara really can do without. And then the last is Niagara floats, sending them to a curve, and then sending that into Metasound. Niagara is a bit more of a polished system, but Metasound really just doesn't have a lot of sort of simple capabilities, and that would include the ability to just have floats go to curves. So yeah, those last 2 are really just to cover Metasound's weaknesses. So this system very much allows for an extreme degree of modularity, right? You can port X to Y. Hypothetically, you could make one visual effect and have 2 different audio sources, 2 different meta sounds, and have 2 different entries in this effects array, which I'll get to in a minute, and just go off that, right? So making it completely modular, maybe you want the same effect but different audio for a bit more variety, or perhaps the audio is informing the V effect and perhaps one of the audio effects is extremely loud and bombastic, and that makes the visual effect really jitter and have a lot of force, and the other one is a lot more subtle, and that makes the effect much more subtle. So they appear as two different effects. That capability is here. So for the sake of example, like I said, the four modes of communication are Niagara to meta, that being V param to S param, meta to Niagara, which is S param to V param, Niagara floats evaluated to and then sent to meta via an execution if one is if the equation responds with true. And lastly is Niagara, and that's under V float to S exec. And then lastly is Niagara floats being outputted to a curve, and that being sent to meta, which is VF curve to S. All of them are an array in which you can input this data, again, very modularly. This is the main core of the project, because otherwise you just have to straight up link each directly within an actor, so you have to create an actor for each. You have to link up each individual type of communication, which is just ultimately not very great. It's extremely slow and naturally just prone to mistakes. So with an example, so we'll look at the chromatic explosion. The chromatic explosion is using the two more elaborate communication methods. So V float to S exec. So it's taking the center explosion callback, which is the big ball explosion, which is just the age of the Niagara effect. So as it gets bigger, so as it's been alive longer, it will go from 0 to 1. Let me just get that up. So in this case, once it has been alive for 0.2, so a fifth of a second, we want, if it's greater than or equal to 0.2, the callback, we want to run the explode execution, and we only want it to run once, so we want it to run as a one-shot. That will not be called again. It will remove it from the array for optimization, so it literally just won't be called again. Straight after that is the rotation rate callback, which is the age of the circling particles. That then sends it directly to a key, which is then played. The callback is sent to a curve, the chromatic explosion spin curve, which is created externally. So this curve could be reused in multiple places. Again, reuse is really key here. And then send it to the rotate float within the meta sound. So yeah, both of them call as such. Then on top of that, we also have to go over the heat map. So the heat map originally it was very difficult to create. You can't just get the color of a pixel from a material. So what you need to do, or from a texture, you need to take that texture, place it into a material, and then print it or bake it onto a render target. The render target needs to be formatted in a specific configuration. It needs to have the same pixel count as the texture in the material. Otherwise, it doesn't line up correctly. So originally, this was running very unoptimally. Every time the intensity was needed, which was very frequently, it would read from the render target, and it would output the color. Now that sounds good on paper, but the problem is read render target raw pixel area, that node, is incredibly unoptimized. It essentially, for the sake of conversation, it essentially goes through each pixel and until it finds it, right? Obviously, that is unacceptable. So what I did as a fallback is I formatted that data into an array of not array, a map of vector2 ints. So the texture is something like 100 pixels. It can really be anything because a map is directly key value paired, so the pixel count really won't affect it, quite honestly. And then yeah, so the values are then mapped well to that map, and the value is also inputted in as a value of that map. So then when we get the data of that, and we need to get the intensity, we can just go into that map. So we are only calling that very unoptimal function once, rather than every time we need to call call it. Yeah. As an additional note, originally the intensity was also stored with all the other parameters. But instead, just for the sake of simplicity, so people don't need to plug in intensity because that could be forgotten, it just looks directly for the intensity parameter by name in both Meta and Niagara. So if a parameter, a float parameter, is named intensity, it will automatically be ported in, just so you don't have to do that every time, because naturally that is one of the main things that will be forgotten. So that's really it. This video is only intended for the systems point of view, so thank you for listening.